This conference will now be recorded.
So guys, in today's class, we are going to talk about a very important chapter, or we can say backbone for storages, which is used in most of the environments, right? LVM, logical volume management. So what exactly is this logical volume management, and in which scenario you think we will be going for LVM? Let us try to understand that concept. See, we discussed yesterday that we can create partition, and in fact we can modify, delete, everything we can do. And when it comes to parted, it also gives you a chance to resize the partition. But there is a limitation and certain risks involved inside it, because of which we try to avoid resizing directly. But instead of that, there is a safe method to resize a partition, especially increasing the size when it comes to LVM. So first of all, let us try to understand that in which scenario we go for LVM. Let us say that I'm having a partition, let us say SDA5 or whatever might be the name, and the size of this partition, let us say, is 1 GB. Now I'm putting some data in this particular partition in the form of a file, right? And I'm storing some data inside it. Let us say I'm adding the data, adding, and at some time this file reaches the size of the partition, that is 1 GB. See, the partition size is 1 GB and the file has also crossed the size 1 GB. Now, if I want to continue writing, what shall I do? Let us assume that resizing of the partition is not possible. Although through parted it is possible, but just assume that resizing the partition is not possible, or there is some risk involved, we don't want to resize the partition. Then what can we do? See, in that scenario, you have only one choice left, that you can take another partition. See, it is also not possible to keep same file in pieces on different partitions, isn't it? I cannot keep some part of a file on one partition, some part on other, and another part on other. File cannot be kept in parts, or directory cannot be kept in parts, isn't it? It needs to be kept in one single drive. So let us say that it is not possible to resize the partition and keep the file in pieces. So in that scenario, I'll go with another partition, assuming SDA6, and the capacity is, let us say, 2 GB, for instance. Then I'll move the data from old partition to new partition, as a result of which half space, that is 1 GB, will be already used, because already the file was having 1 GB data. In remaining 1 GB space, I will continue to write. I will write, and at some time that 2 GB space will also be utilized. Then what would you do? So in that scenario, you would prefer going with 4 GB, for instance. Now at one time that 4 GB will also get filled up. Then you'd prefer going with 8 GB. Now at one time that 8 GB will also get filled up. Then what would you do? Then you'll go for 16 GB, 32 GB, 50 GB, 100 GB. Like that, you would keep on moving from one partition to other and other to next. See, okay, you can move from one partition to other and other to next like that, but moving the data from one partition to other partition requires a downtime, right? While the applications are in use related to that data, or maybe it's a database related to our data. So while they are in use, I cannot move the data from one place to other place. It needs a downtime. And guys, do you agree with this thing that your customer will not be able to give you downtime every often you're asking, right? Whenever you ask for a downtime, they might give it at their convenient time when business is not high on that time, or maybe midnight, something like that. Now, suddenly there is a space issue came. You cannot ask for downtime. So there are some problems that are involved if you go for moving the data from one place to other place in this particular scenario, right? Because downtime is required and downtime would not be given whenever you are asking, right? So all these things are there. To avoid them, we prefer going with LVM concept. So how LVM actually works? See, in this scenario, what I'm going to do is I'm just trying to explain you the overview of LVM. Then we will go in deeper part and understand all the components of LVM. So first of all, you just see that how LVM works. See, in LVM, what we does is we will take a physical partition, let us say SDA 5 or 6. Let us say the capacity is 1 GB of that partition. Basically, that partition size can be anything. For example, I'm taking 1 GB. Now, using the space of that SDA 5, we are going to create a virtual partition. Now, you know what is virtual. Virtual is something which is not real, which does not really exist. It's kind of illusion, you can say, what we create. So what we do is we create a virtual partition by using SDA5. Now, what would be the size of this partition? See, the size of this partition would be 1 GB, not more than that. If you have 100 bucks with you, you cannot spend 200 out of it. So 1 GB physical space is there. So maximum you can go for 1 GB virtual space. Now what we do is we show our operating system that this is your virtual disk, which is a real disk kind of thing, right? We'll format it, we'll mount it, we'll try to store the data in all that virtual location only. But whatever you are trying to store in this virtual disk, for example, I created a file and I'm trying to store the data. So whatever you are trying to do in this virtual partition will actually be mapped to your physical partition. Virtual only shows that I exist. But whatever you are trying to store inside it, actually behind the scene, it is going to get stored on the virtual, on the physical partition. I'm sorry. Now, see, the capacity was 1 GB, 1 GB. The physical capacity is 1 GB. Virtual capacity is 1 GB. Totally is utilized. Now, what can I do? We know, guys, that there are some issues when increasing the size of physical partition. We cannot increase, decrease physical partition so freely. But how about virtual? See, virtual is something which is not real. If it is not real, I can play with the sizes over here, right? So in that scenario, what I'll do, I'll simply take another partition, let us say SDA6, whatever might be the size. Let us say the size is again 1 GB. Now, this physical space I'm going to dedicate to again that virtual partition. So what would be the size now about that virtual partition? 1 GB of SDA5, 1 GB of SDA6. Front end, it will show that I'm having 2 GB capacity. So automatically the size of that virtual partition will get increased. And whatever you continue to write, it is going to get stored this time in SDA6. So the whole story is It just combine multiple partition sizes and create one big virtual partition. So front end, it looks like as if it is one single partition, but backend, it is nothing but combination of multiple partitions. So many partitions clubbing together to give front end a big size. This is nothing but the workflow of LVM. Front end, your virtual partition will show as if it is a real partition and it is one big size partition or big size volume. Behind the scene, it is nothing but combination of multiple partition from multiple disks. It is not possible, it is not like that you have to take only the partition from SDA. You want, you can take partition from SDB disk, SDC disk. One disk can be SCSI, one disk can be SAS, one disk can be SATA, whatever it might be. So you can take spaces from different disks and make it as one big size volume, right? So that's how the things would be working. This is again not a complete picture. It is only an overview what I want you to understand. So front end, it looks like as if it is one single drive, but in the backend, it is combination of multiple partitions. So many partitions coming together to form one big size volume. That is nothing but LVM, logical volumes management. Now let us try to go into the deeper section of LVM and let us try to understand each and every component of LVM. See, the first requirement of LVM is to have a partition, right? So let us say that I'm having this partition. Any name of this partition might be maybe SDA6, and whatever size of that partition might be 1 GB, 2 GB, 10 GB, 100 GB, whatever it might be. Just for explanation purpose, I'm assuming that the size of this particular partition is, let us say 1 GB. Okay. Normally, I'm telling it partition kind of thing. But in LVM concept, we call it as physical volume. Something which is physically available, we call it as physical volume. Now, using the space of this physical volume, we are going to create one container where all these physical volume spaces are stored. So what do we call this container? Container, we are going to call it as volume group. In short, VG. PV stands for physical volume, VG stands for volume group. So volume group is nothing but a container or a collection where the physical volume spaces will be stored for a particular application or database for wherever you want to use it, right? Consider volume group is nothing but like a bank, and physical volume is nothing but the money. So you have a money, what you have done, you have deposited that money into your bank account, right? So you have a physical volume, you have deposited the space in volume group. So how much space do you have in the volume group as of now? I have 1 GB, right? So with that 1 GB, what you can do? See, it's up to you. You can use all the space at a time, or you can use few space and keep remaining space for future. It's your account, it's your money. Whatever amount you want, you can withdraw. You can use it. You can withdraw all money at a time, or you can use few money and keep remaining amount in your account for future usage. Same way, we can work with this LVM concept. So what we'll do by using the space of volume group, we will create a virtual volume, something which is not real in nature. So this virtual volume, what we are going to create, we call it as LV. LV is nothing but logical volume. The whole story is revolving around logical volume only. LVM stands for what? Logical volumes management. right? So by using the space from volume group, you have to create a logical volume. Now, what could be the size? That depends on you. You can use all 1 GB and create one logical volume, or you can use 512 512 and create two logical volume, or you can create four logical volume, 256 MB, 256 MB, 256 MB, 256 MB, or you can just use 512 and keep 512 for future. So what size you are going to create, that depends on how much space you are having in volume group. You can use all space, or you can use some space and remaining you can keep it for future usage, right? So this is how LVM workflow will be going on. We take a partition, we add it into a volume group, and from volume group we'll borrow the space and create logical volumes. One more thing is there. Let us say I have used entire 1 GB and created a logical volume, for example. Now, one more thing is there, that when we add a PV, listen to me very carefully. When you add a physical volume into a volume group, automatically the physical volume will get divided into small partitions inside it. For example, 1, 2, 3, 4, 5 partition. Just for understanding, I'm telling you that, suppose, assume for 1 GB, 5 small partitions are created inside it. Now, what do we call these partitions? See, these partitions are called as physical extents. Generally, they are small partitions that are getting created in physical volume. So physical extents are nothing but the small partitions that are getting created inside physical volume. When? When you add it into a volume group. Same way how physical volume got divided into physical extent, same way your logical volume will also get divided into some partitions. For example, 1, 2, 3, 4, and 5. What do we call these partitions? These partitions are called as logical extents. Physical volume is divided into physical extents. Logical volume is divided into logical extents. Okay, we understood that. But what exactly is the role of these physical and logical extents? See, I told you that you format logical volume, you will mount logical volume, and you will try to store data in logical volume. But as I told you that logical volume is not a real storage partition. It cannot hold the data. But whatever you are trying to store in logical volume, it has to mapped to a physical volume. Suppose I'm trying to write the data in logical volume in this fashion: A, B, C, D, E. Now this data has to be stored on my physical volume. How it is going to get stored? Every logical extent will be mapping to its subsequent physical extent to store the data. For example, first will be mapping to first physical extent, and A would actually get written there. Second will be mapping to second, and B will be written here. Third will be mapping to third, and C would be written here. See, there is no rule that first LE should map to first PE only, or second should map to second, right? Here mapping will happen based on availability. How many extents are free? So it depends. Fifth can map to first also, third can map to fourth also. Depending on availability, that mapping would be happening. Anyway, fourth will be mapping to fourth, and D would be written here. Fifth would be mapping to fifth, and E would be written here. Now suppose that this space is totally utilized. I need more space to continue writing. 1 GB is totally utilized. So what I'll do, very simply, I'm going to take one more partition. Let us say SDA7 or SDB7, whatever might be the name. Let us say the capacity of this fellow is also 1 GB. Sizes can be anything, only for example, I'm using 1 GB. Don't standardize 1 GB. You can use whatever size you want. Now we will add this physical volume into your volume group. See, as soon as you add a PV into volume group, first of all, it is going to get divided into partitions. For example, 1, 2, 3, 4, 5. And the capacity of your volume group will increase from 1 GB to 2 GB, from which 1 GB is utilized and 1 GB is free. Now, with that free space, you can increase the size of logical volume, or if you want, you can create more logical volumes. That is purely depends on requirement and your choices. So my requirement is to expand the size of this only LV I'm having. So let us say that I will expand the capacity to another 1 GB. Now, when you expand the capacity of logical volume from 1 GB to 2 GB, not only the size of LV will increase, but total number of extents will also increase. Earlier, I was having 5 extents, but now you see total number of extents will increase to 10. So another 5 extents will be added. And let us say you are continue to writing F, G, H, I, and J. Now how it would get stored? Same scenario, but here your continuation will be done in next partition. Sixth will be mapping to first and F would be written. Then seventh would be mapping to second, G will be written. Eighth will be mapping to third, H will be written. Ninth would be mapping to fourth and I would be written, right? 10th would be mapping to fifth and J would be written. So that's how the mapping or the storing of data between physical and virtual would be done with the help of these extents. So these extents are really important in mapping the data from your physical to virtual and virtual to physical, right? Whenever you are reading the data, you have to approach physical volume to get your data. Whenever you are writing, your logical volume needs to approach your physical volume. So where exactly your data is stored, that is known by this logical extents or physical extents only, right? So this is the way LVM will do reading and writing activities. Now, one last thing, these logical extents or physical extents, whatever we are talking, these extents also of some size. So what would be the size of extents? Let's try to talk on that. The size of extents you have to decide when you are creating a volume group. So while creating volume group, you need to decide what would be the extent size. And you have to choose the size between this range. 1 MB, 2 MB, 4 MB, 8 MB, 16 MB, 32 MB, 64 MB, or maximum 128 MB. So between this size, you have to choose whatever size you wanted to give, right? So it's depending on your requirement. Suppose I have selected a size 4 MB. Now guys, when you have selected while creating volume group, you told volume group that the extent size should be 4 MB. When you said that the extent size should be 4 MB, then volume group is going to be very, very strict with this size. How many physical volumes you are adding in this VG? How many logical volumes you are creating in this volume group? All of them will have 44 MB, 44 MB, 44 MB extent size only. It is not possible to have two different extent size in a single volume group. SDS6 will have 44 MB partitions, SDS7 will have 44 MB partitions, right? And your logical volume what you have created will have will also have 44 MB. It is not possible that SDS6 you can give a different extent size, SDS7 you can give a different extent size. That is not going to happen. Volume group will not allow you to do that. And also it is not possible that physical volumes are having 44 MB, logical volume you can give 88 MB. That is not possible. See, that is the reason while creating volume group, it will ask you for extent size, right? While creating PV or LV, it will not ask you extent size. So volume group will maintain that extent size, and it would be very strict about it, right? So how to choose this extent size? See, if the partitions you are going to add in the volume group are smaller in size, maybe 1 GB, 2 GB, then you can choose a smaller size, 1 to 8 MB. Or if you are planning to add bigger size partitions, maybe in 50 GB, 40 GB, or maybe in TBs, then better to choose bigger size, right? But once this partition size is chosen, your volume group is going to allocate that only, how many PVs you add, how many LVs you create. One more thing is there, that if you forgot to mention extent size, suppose I have created a volume group, but I did not mention any extent size, then what will happen? Then it is going to choose a default extent size. And what is the default extent size? 4 MB. 4 MB is your default extent size. If you forgot to give any extent size, then automatically it is going to take 4 MB, right? Now, is it possible to change extent size once we create volume group? That we will discuss in the coming time when we create practically this partition and all, right? So as of now, this was a theoretical aspect related to LVM, that we take a partitions, we will add it into volume group. From volume group, we will take the space and create logical volumes. What's the benefit of going with logical volume? The benefit is whenever you want to expand the capacity of logical volume on the go without disturbing any applications, without disturbing any databases or whatever application that is related to LVM, you can expand the capacity. In no time, you will find that the space of your logical volume increased and there would be no disturbance in your workflow. In fact, you can also decrease the capacity whenever you want. So it is a flexible volumes whose size can be increased or decreased on demand whenever you wanted to increase or decrease the size of this logical volume. So such kind of thing are very important for critical environment where downtimes are not possible so often. So in this scenario, LVM will resolve that issue for us, and it gives us a chance to manage our environment storage without downtime. Now let's move ahead and let's see what are the command lines that we are going to work with LVM. Now let me just power on the machine for practicals. Meanwhile, we discuss the last theoretical parts. One second, guys, just a moment. Oh, there's okay. Let me just power on. Okay, let it get powered on. Meanwhile, we'll discuss the command line that we will work with. See, all these abbreviations and the definitions all are available in the manual, so please have a look on it after the class. So let us see that what are the command line that we're going to work in LVM. LVM command line is again a simple command like other Linux commands. Like we have PVS to display all the physical volumes, VGS for displaying all volume groups, LVS to display all the logical volumes. But this PVS, VGS, LVS will give you a brief information, small information about PVs, VGs, and LVs. If you want to see them in detail, then you have to go with PV display, VG display, LV display. This is going to show you in detailed output. To create a physical volume, PV create. To create a volume group, VG create. To create a logical volume, LV create. To extend the volume group, extending the volume group is nothing but adding a new physical volume into volume group. We call it as VG extend. And to reduce the volume group, reducing is nothing but removing a physical volume from the volume group, right? So VG reduce. Same way, if you want to expand the capacity of logical volume, you can say LV extend to increase the size of logical volume. To decrease the size of logical volume, we will go with LV reduce. LV extend to increase the capacity of LV. LV reduce to decrease the capacity of logical volume. But guys, when it comes to LV, we have one more wonderful command, LV resize. See, LV extend can only increase the capacity of LV, and LV reduce can only decrease the capacity of LV. But we have a neutral command, LV resize, which can increase as well as decrease both activities in LVM. To move the data of one PV to another, we use PV move to move the content of one physical volume to the other. Then finally, to get rid of LVM, you can say LV remove to delete a logical volume, VG remove to delete a volume group, and PV remove to remove a physical volume. So these are the command lines what we are going to use in LVM. Hopefully our system is booted. Yes, it is booted. So let us log in and let's try to do some practicals related to LVM that will clear all our theoretical doubts and aspects. So let me log in into it. First of all, I'm going to check PVS. There is no PV. VGS. There is no VG. LVS. There is no LV. Now let us say I want to initiate LVM concept. To go with LVM concept, the first thing you have to do is you have to create a partition that can be used as a physical volume. So as you see fdisk-l, all the partitions created are used. We have used it for formatting, mounting already. So I don't want to disturb them. I would like to create one more new partition that we are going to use for LVM concept. So in that scenario, what I'm going to do, I'll go with fdisk. You can create a partition with fdisk or parted, you know how to do that. As I personally prefer fdisk, I'm going with fdisk. To add a new partition, you can say first of all P to print the partition table. Then you can say add a new partition. Starting values are perfect. As I can see, I'm not going to make any change. I'll just accept it by hitting enter. Now the size I would like to give is, for example, 512 MB. Now this size depends on your requirement. You can create a partition with 10 GB, 50 GB, 100 GB, your choice. I'm having small size remaining, so I'm going with a smaller size, 512 MB. Let me hit enter. So it says that previously you have created SDS7 and used it for swap. Do you want me to remove that signature? Yes, go ahead. I don't want any previous signature to be remaining. Now print the table and see SDS7 is created, right? But it says that SDS7 is created as a normal regular partition. See, I'm not going to use it for a normal regular concept. I'm going to use it for LVM purpose. You remember yesterday when we created a swap. So to make sure that it works perfectly with swap, we change the ID to 82. Same way, if you want to use a partition for LVM concept, then you must change the ID to 8E. 8E is for LVM purpose. I showed you yesterday. So to change the ID of the partition, we used yesterday T to change the type. I'll say I want to change the type for 7, and what should be the code. If you know the code, you can directly type it. If you don't know the code, then you can type L and list it out. So here you can see 8E is for Linux LVM. So I'll say I want to use it for LVM, so I'll give it 8E. Now print the partition table and see that SDA7 is created. 512 MB is the capacity and 8E is the type what we have selected. Now if you want to save and quit, you have to type W. Changes have been updated. Now if you run fdisk-l, you'll find SDA7 is added successfully. And if you check the kernel status, proc partitions, so you'll find that SDA7 is updated over here also. So that's the way how you can go for creating a partition compatible with LVM. Now I need to create a physical volume by using SDA7. So far SDA7 is a normal partition. I should convert that partition into a physical volume. So step number one, as I showed you, create a partition with 8E capability. Done. Now you have to create a PV by using that simple partition by using a command PV create and partition name. Suppose if you have created two partitions with 8E, you can say PV create SDA7 as well as SDA8. So both partitions will be converted into PV. So I'll say PV create. I have only one partition created as 8E, so I'll say SDA7. Create a physical volume by using dev SDA7 partition. Now let me hit enter. You run pvs. So you see it says dev SDA7 is now a physical volume which is not part of any volume group. It's a free PV, does not belongs to any volume group. LVM2 is the format. See, LVM is also a software. Every software will have a version. And what is the version we are using here for LVM? It is LVM2. What's the capacity? 512 MB. An entire 512 MB is free. That's what it is telling you. But if you want to see a detailed output, you can say PV display. PV display will give you a detailed information that what is the PV name, it belongs to which VG, what's the size, is it allocatable or usable? It says no. You know why it is telling no? The reason is it does not belongs to any volume group so far. When you add this PV into any volume group, then your PV will get extents. So far, you see there is no extents allocated. There are no free extents, used extents, total extents, right? Nothing is there. When you add this PV into a volume group, then extents will be created and the space will automatically become allocatable or usable. So let us use SDA7 and create a volume group. See, you have a choice here. If there is an existing volume group, you can add it to that volume group. But in our case, there is no volume group available. So you can create a fresh volume group by using SDA7, right? So to create SDA7, to create a volume group using SDA7, we go with this command, guys, vg create, right? Let me show you the syntax first. So we'll go with vg create you have to give some name for the volume group. Now, guys, there is no proper naming convention for volume group. Whatever name you like, you can call it, right? And you have to give the free PV name. So suppose I want to create a volume group with the name myVG. So I'll say VG create with the name myVG. Now make sure that this name is not already taken, otherwise the command will fail. Then I will be using that free physical volume SDA7. Now SDA7, I'm asking it to be a part of my VG, so it should be a free physical volume. It should not be already part of other volume group. Guys, it is not possible that one physical volume can be a part of two volume group. Suppose I have two volume group, my VG and SAP VG. So SDA7 can be a part of my VG or it can be a part of SAP VG, but it is not possible that half space you will give it to my VG and half space you will give it to SAP VG. That is never going to happen. So one PV at a time can belong to one volume group. That's it. It cannot be part of multiple VGs. Remember this particular concept. Okay. All right. So as we can see, SDA7 does not belongs to any volume group. It's a free PV. So I can easily add it to my new volume group. So I'll say VG create. Simple command line is there. I want to give it a name myVG. I know there is no other volume group with this name, so it would definitely get created by using slash dev SDA7. So very simple. I'm telling create a volume group with this name by using so and so physical volume. And now you say PV display. First of all, you see last time there was no volume group. It says it does not belongs to any volume group, but now you see it says it belongs to my VG. And also allocatable was no, and automatically allocatable becomes yes. As soon as you add a PV into volume group, it becomes usable. As it is usable, that means you can use it further and create logical volumes also. And if you observe here, while creating volume group, I did not mention what should be the extent size. What did I told you that if you don't give any extent size, then automatically it is going to take 4 MB. Total number of extents got created is 127. How many are free? 127. How many are used? Nothing. And also guys, it is showing you some PV ID. Every component will have an ID. PV will have PV ID, VG will have VG ID, LV will have LV IDs, right? Anyways, but one question here is how it got 127 extents. The answer is, guys, total size divided by physical extent size. That means 512 MB divided by 4 MB should be 127 extents. Like that it should be, right? Let me show you the calculation. I'll go to built-in calculator. See guys, in Unix and Linux, we have a built-in calculator. You have to call it by typing BC, built-in calculator. Now over here, you can say 512 MB divided by extent size 4 MB. Now let me hit enter. Total result it should tell me is 128 extents. But how many extents I got? 127 extents. So where is that one extent missing? If you observe here, it says that the total capacity is 512 MIB, but out of it, not usable space is 4 MB. See guys, the thing is, in LVM, we have a concept called metadata. Now, what is that metadata? Metadata, normally metadata is data about some other data. Same way here, metadata is nothing but the information about your entire volume group. What is the name of volume group? what is the physical volume it is having, what is the PV IDs it is having, how many LVs are there inside it, what are their LV ID, how many physical extents are there, how many logical extents are there, which physical extent is mapping to which logical extent. All that information is stored in metadata. So every PV you are adding into volume group will get a copy of metadata to have information about the volume group. And to store that metadata, one extent size will be reserved. For example, extent size is 4 MB, so 4 MB will be reserved in that physical volume to store metadata. Suppose the extent size is 8 MB, so 8 MB will be reserved. Suppose the extent size is 16 MB, so 16 MB it will try to reserve, right? But anyway, it will try to reserve some space for the sake of metadata. So the calculation goes like this. 512 minus 4 MB is what? 508. So now you say 508 divided by extent size. So that's how you are getting 127 extents. Although the capacity is 512 MB, but 4 MB from the partition is reserved for metadata. So total usable capacity is 508 MB. So 508 MB, when it is divided by total extent size, that is 4 MB, you got 127 extents. To come out of this calculator, you have to press Control D. Control D will log you out of the calculator. All right, fine. Now we came to know that we have a PV. Now I'll check about VG. When I say VGS, it says I have my VG with 1 PV and 0 LV. So far, there is no logical volume inside it, right? And you see the capacity is 508 MB. It is not showing 512 MB. You can check the details about the volume group by going with VG display. So VG display will show you the detailed information about your volume group. So what's the name? My VG, right? Format, LVM2, metadata areas, only one. See, if you have one PV added, you'll see one metadata. If you add two PVs, you'll see two copies of metadata. Each partition or PV you are adding into volume group will get a copy of metadata. And observe here, guys, there is no limit in how many maximum LVs you can add or how many maximum LVs you can create or maximum PVs you can add. You can add n number of PVs. You can create n number of LVs. See why I'm stressing on this point? Because LVM is a concept that is used globally in all Unixes, right? So some Unixes has limitations. Like if you go with IBM AIX and if you implement LVM over there, the limit of physical volume is not more than 1024. So you cannot add 1024 or more than 1024 physical volumes, and total number of logical volumes are restricted to 512. You cannot go beyond that. But thankfully, in Linux, we don't have any limit. Any number of PVs you want, you can add. Any number of LVs you want, you can create. That's the benefit of doing LVM in Linux environment, right? So now you see the size of this volume group is 508 MB. Physical extent is 4 MB. Total extents you got is 127. Beautiful explanation. Total size divided by extent size has given you number of extents. How many extents are used? Nothing. How many extents are free? 127. And what is the space? 508 MB. So it shows you the usage in extents and sizes also. Now guys, suppose in this volume group I would like to create a new logical volume. So if you want to create a new logical volume inside it, what should be the size of that LV? See, if you want to create a logical volume, you have to start with at least 4 MB, because at least one extent you will give. And what is the size of extent? 4 MB. So minimum logical volume size you have to start with is 4 MB. You cannot give 2 MB or 1 MB because one extent has to be used. And what is the size of one extent? 4 MB. And maximum size you can allocate as of now is 508 MB. Say as of now the capacity is 508, so you can go to 508. But if you give create 700 MB or 800 MB LV, it will fail because that much capacity is not present in your volume group. If you want to create 700 MB, 800 MB, then first add one more PV into volume group. Give the volume group more space. Suppose you have a bank account, you have 100 bucks inside it, so you can use all 100 bucks, but you cannot spend 200 out of it. If you want to spend 200, first you must add money to your bank account and then you can spend it. Same way the requirement goes here also. So whatever size you are choosing for your new logical volume should be between 4 MB to 508 MB. So I can create a logical volume for 300 MB easily. See, 508 MB is entirely free, so I can create 300 MB logical volume very easily. So let us see what is the command line to create a logical volume. To create a logical volume, we go with a command lv create, right? I'll say lv create hyphen capital L. That capital L stands for size of LV in KB, MB, GB as per your requirement. Hyphen N to give name for LV. Guys, hyphen N is important if you want to avoid confusions. Give some name of your choice which you can understand better. If you don't use hyphen N or if you don't give name, then it will auto generate some name that would create sometimes a confusion for your understanding. So it's always highly recommended, not only recommended, but highly recommended that you should give some understandable name for your LV, followed by from which volume group you want to take the space or in which volume group you want to create it. So it is lv create hyphen L. Suppose I want to create a logical volume 300 MB hyphen N, some name. The name is my LV. Now make sure that this name is not already taken by other LVs. And I want to create it inside my VG. So I'll say lv create hyphen capital L, and I would like to give a size 300 MB hyphen N. I want to call it my LV, and I want to use the space in my VG. So I wanted to create 300 MB of logical volume with a name my LV by using the space from my VG. Let me hit enter and you see your logical volume is created. Before I can show you logical volume details, let us go with VG display. So you see out of 500 MB, 300 MB is used. And now I'm left with 200 MB free. Same is 127 extents are total and used is 75 extents, free are 52. So it is showing you the usage in sizes and extents both. Now you can check LV details by going with LVS. It says I have only one LV whose name is my LV, belongs to my VG, which is currently active, and the size is 300 MB. You can go with detailed information by going with LV display. LV display is telling you that the the path is dev my VG, my LV. See that location, what it is showing is really important. Otherwise, you see here, it is telling the name is my LV and the name of VG is my VG. Why it has specifically mentioned that path? What is the significance of that path or where that path is really important? See guys, after creating LV, you have to format it the way you format normal partition. And to format the LV, you have to give address of LV. And here it is mentioning you the address that in slash dev, there is my VG, in my VG, there is my LV. So that path is really important to format the LV, to mount the LV. In fact, if you want to make a permanent mount, you can make use of that path. So that you should not forget that path. That path is already mentioned on the top for you, right? So you see this is LV name, LV ID, and read write access is available. At what time this LV got created, it is giving you the detail. LV status is open, active, in use. Right now, LV is available, but it is not open. Open, it is telling you, is 0. 0 means right now this LV is not open for reading and writing the data. If that status is showing 1, 1 means it is really open. 0 means it is not open for reading, writing. Now, when that 0 will become 1, and when we say that it is open for reading and writing. See guys, if you have a partition, you want to store the data in the partition. When you can store the data inside it? When it is mounted. When a partition is mounted, it is open for reading and writing. When a partition is unmounted, it is closed. It is not open for reading and writing. So same thing is here. If a partition or if the LV is mounted, it will show 1. That means it is open for reading and writing. If the LV is not mounted, it is going to show you 0. That means right now this LV is not mounted. But guys, before I can show you mounting and unmounting, we should first format the LV. We should give it some file system. So how can I format it? To format it, we have to use the same command mkfs. Now you can use ext file system or xfs, that is your choice. But the path of my LV I'll give is dev my VG my LV. So I'm telling that format this LV using ext4 file system. Now let me hit enter. So you see it formatted and it has also generated UUID. You know very well how and where to use that UUID concept for the file system. Right now, after formatting, it's time to mount it. And to mount it, I'll create first of all a directory or a mount point. I'll say mkdir, some directory you can create. For example, I'll create a directory with a name called /my. Now let me mount it. Same type of mounting. See, up till now we were working with a simple partition. Now we are working with LVs. So I'll say mount the full path of LV. What is the path? Dev my VG my LV. I want to mount it on /my. Now you can just check it out with mount and tail. It shows you that my LV is connected to /my. And as soon as it is mounted, observe the status of LV. Open status was 0. And now it is showing what? 1. So as soon as the LV is mounted, the status will change to 1. And if you unmount it, I'll say umount /my. You can check it out with mount command is not yet mounted, right? And if you run LVS or LV display, you'll see that open status has been changed to 0. Let me mount it again. I'll say mount /dev my VG my LV on /my. Check with mount command, you'll find that my LV is mounted on /my. Now you check LV display, open status is changed to 1. Now anything you want to store in my LV, you have to do it with /my mount point. So let me go into that mount point, right? And let me try to store some data. I'm creating some 100 files inside it. Now where are these 100 files going to get stored? See, it will appear as if these 100 files are stored in your logical volume. But actually, from logical volume, they are mapped to physical volume. How can I check that mapping? That this LV is connecting to how many physical volumes and where it is storing my data, I want to check. So if you want to check the mappings, then you can say LV display hyphen M to display mappings also. So it is going to show you simple LV details, and at the bottom it tells you that in that logical volume you have extents 0 to 74, which is getting stored on dev SDS7, and on SDS7 the physical extents it is connecting is 0 to 74. So by using hyphen M you can see that this LV is storing the data on how many physical volumes, and each physical volumes what extents it is connecting to. Same thing you can check out with PV display also, but I'll tell you that later. First of all, I want to make this mounting permanent. See, to make a mounting permanent, you can use this UUID if you want, or you can simply use the name also, as we have seen, right? So your choice, you can go with UUID, you can go with name. I want to go with name to keep it simple. Otherwise, you can go with UUID also. So I'll go to ETC FS tab. Let me open a new line by typing small o. A new line is open and you are in insert mode. First of all, I will type UUID, or I'll type the full path of LV, dev my VG my LV. Then I will say that the mount point is slash my. Type of file system I have used is ext4. Mount options are defaults. Dumping is 0 and FSCK is 0. Now let me save and quit. I will unmount slash my. You just check it out, mount and tail. You see, it is not yet mounted. Check with LV display, the status is showing 0. Now let me run mount hyphen A. Go with mount and tail, you'll find my LV is connected to slash my, right? And you say LV display, you will find out that the open status is showing as 1. So this is the way how you can create a logical volume, you can format it, and you can mount it, right? Now guys, when I say PV display, it is going to display all the physical volumes you are having. In our case, we have only one, but suppose if we have 10, all 10 PV details it will display. Let us say I don't want to see 10 PV details, I just want to see one or maybe two PV details. So you can say PV display, show me only the detail about SDS7 and SDA9 if two PVs. If only one PVs, just say show me the detail about SDA7. Same way, if you want to see mappings of SDS7, so you can add hyphen M. So it tells you that SDS7 is holding what? So it says SDS7 is holding the data from my LV and the logical extent 0 to 74 that are being used on this physical volume. And how many are free? From 75 to 126 physical extents are free. Same way, if you say LV display or maybe VG display, if you say VG display, all the volume groups that are available in your system, it will show the details for all. Let us say I'm not interested to see all volume groups detail. I just want to see details about my VG. So you can say VG display, show me the detail only about my VG. Okay. All right. Same way, if you say LV display, it is going to show you the details about all the logical volumes. So over here, if I say LV display, show me the detail only about my LV, it says not found. Why it is telling you? Because when you say LV details, you have to give
path of LV that you are interested in. Giving name may not work in LV display. So I need to say LV display, show me the detail exclusively about dev my VG my LV. So that is how, guys, you can create PV, VG, LV. You can format it, you can mount it, and you can make a permanent mount also by editing etc fstab. Right now, very quickly, I'm going to show all the steps one more time with new PV, new VG, and new LV. So let me quickly go to fdisk slash dev sda. I'll add a new partition. Starting sector is okay. I'll give the size 512 MB. Print 8th partition is added, but it is not compatible with LVM. So I'll use T to change the type of 8th partition, and the code I would use is 8E. Right now, print the partition table and see SDA8 is also compatible with LVM. Now let me save and quit. So you see SDA8 is added. Now I need to convert SDA8 into a physical volume if I want to use it for LVM. So I'll say PV create. If I say dev SDA7, it says it is already created and it is a part of volume group. You cannot create it anymore. So I need to say PV create slash dev SDA8. Now you say PVS, you'll find SDA8 is a part of my VG, right? Fine. Now it's free. You have a choice. If you want, you can add this fellow into my VG if you want, right? Or you can use it for a new volume group. My choice is to use it for a new volume group. To create a volume group, we saw the command. We'll say VG create. Suppose I'm going to create it with a name called Aura VG. Maybe I'm creating it for Oracle applications, so I want to use it for Aura VG. So I'll call it Aura VG, and by using dev SDA8. See guys, if I run this command, it is going to create a new volume group with SDA8, and again it is going to take what? 4 MB as its default extent size. But I don't want it to take default extent size. I want to give my choice extent size from 1 to 128, whatever size I want. So suppose I want to give 16 MB extent size. So you have to say VG create hyphen S 16. 16 means each extent size should be 16 MB. Now, first of all, you run PV display dev SDA8. So you see SDA8 is a part of Aura VG, capacity is 512 MB, allocatable is yes, extent size is 16 MB, and you see not usable is how much? 16 MB. As I told you that one extent would be reserved for the concept of metadata. So close to one extent or exactly one extent size it is going to reserve. Total extents I got is 31. How I got 31? 512 MB minus 16 MB. So let's calculate it. 512 minus 16 will be 496. Now 496 divided by 16 MB, the extent size, will give you 31 extents. So that is how you got 31 extents in this volume group or physical volume. I'm sorry. Now you check VG display. I only want to see details about Aura VG. So you see total capacity is 496 MB, extent size is 16 MB, total extents I got is 31, nothing is used, entire 496 is free. Now in this volume group, if I want to create a new logical volume, I have to start with a minimum size 16 MB. I cannot give 4 MB or 8 MB because extent size is 16 MB. At least one extent I have to use and minimum value will be 16 MB. and maximum capacity you can go up to 496 MB. So between them, whatever size you want, you can choose. Suppose I want to create a logical volume with 200 MB. So I'll say LV create hyphen capital L. I want to give a size 200 MB. I want to create LV with a name called Aura LV, and this should be done under Aura VG. See, it may throw a warning or message that I cannot choose 200 MB as per the extent size because 200 is not divisible by 16. So to make it proper, I took 208 MB. That's fine. That's okay. Now, if I say LV display, you see Aura LV is created. What's the path? Dev Aura VG Aura LV. And right now it is not open because it is not mounted. First of all, I'm going to format it. I'll say mkfs.xfs slash dev aura vg and aura lv. Last time I used ext. This time I'm formatting with xfs. Now I'm going to create a directory, maybe with the name aura, and I'll say mount. Mount what? Dev aura vg aura lv on slash aura directory. You run mount and tail, you'll find that aura lv is connected to slash aura. You say lv display slash dev aura vg aura lv, it says the open status is 1. I can store the data in aura. I'll come over here and I'll say my lvm, some files I'm creating. Now these files will appear as if it is storing in Aura LV, but actually through Aura LV, you know the logic, it is going to get stored in a physical volume. Anyway, if you want to make it a permanent mount, then go to etcfs tab, open a new line. I'll say slash dev Aura VG Aura LV, right? And the mount point I'll give is slash Aura. Type of file system is XFS. Mount options, defaults, no dumping, and no FSCK. That's it. So this is the way, guys, how LVM works. So this is just the half part of LVM. Remaining half, or the advanced part, increasing, decreasing the sizes, moving the content from one PV to other, deleting, and few other things we have to discuss in tomorrow's class. So for today, I'm going to stop here. Any questions if you have, guys, you can put your questions now. Oh my God. Physical extent is actually a physical place, Hamsi, where actually your data will be stored. Whatever we are trying to store in a logical volume, it has to be mapped to physical volume. So physical extent is a part of physical volume that will be connecting to logical volume. It's a pipe. LV will be connected to PV. Whatever you are trying to store in logical extent will be mapped to physical extent and it stores the data, right? I told you with a drawing, so you can just re-watch the video, the beginning part, to understand that concept. But every logical extent will be mapping to physical extent. So your physical volume will have a partition, logical volume will have a partition. So this partition will map to that partition. If you write anything here, it will take it to physical extent and store it on a physical partition.
Yeah, I'll watch for the video and any
Yeah, please
question I
watch.
have, you know. Yeah.
Yeah, sure, no problem, no problem at all. But please rewatch the video if you have a confusion, and still if you have confusion, let me know. I'll try to go in more detail then. there's other batch I have to start immediately after this class. So keep your questions. If you have anything, practice it and let me know, guys. If you have any further question, tomorrow's class we can take up the questions also. So please first practice, and then tomorrow's class we will take questions and we will proceed with the class. Thank you very much, guys. See you tomorrow.
Thank you.